Hello, welcome back. Here we are with our fourth section of Unit 5 in our polynomials unit, and we are going to be factoring again. You know how important factoring is, and most of this is not going to be new to you, but there are going to be a couple of things that are going to be new to you, but we really just want to make sure that we're really comfortable with factoring in general, because factoring is going to be one of the first steps in a lot of processes that we're going to do from here on out. So we really want to make sure that we're not spending a ton of time figuring out how to factor so that we can spend that time actually doing the whole process for the problem. So how do we factor polynomials? Well, we're really good at factoring like quadratics or factoring things that are very familiar to us, but we are going to encounter some things that aren't so familiar to us, and so that's what I want to help you out with. On this left-hand side, I give you this like flow chart to kind of house all the information of different ways that we can factor. So first step, no matter what, I don't care how many terms you have in the polynomial, the first step that you want to do is always look for that GCF, that greatest common factor. And remember, your GCF doesn't always have to be a number. Your GCF can be a variable. Maybe every single term has an x cubed. Maybe every single term has an a, whatever. But it can also be a number, and it can be a number and a variable. Maybe every single term is divisible by 3b or something like that. So always want to look out for that GCF first. Then it's kind of based on how many terms the polynomial has. 2 terms, binomial, 3 terms, trinomial, 4 terms, etc. If it has 2 terms, we want to look out for these 2 specific types of polynomials, and that is the difference of squares, which we already know how to factor. Remember, that looks like something squared minus another number squared. So you see 2 perfect squares being subtracted from one another. That is the difference of squares. And you factor that by simply taking the square root of the first, the square root of the last, using one positive and one negative. So something like x plus a and x minus a. An example of that, if you actually look right on over to the right-hand side, is 49x squared minus 64. 49x squared is a perfect square, and so is 64. First thing I would want to do, though, just to remind you, is look for a GCF. There is no GCF. Then I say, oh, there's 2 terms. Both of them are perfect squares. So I know, sorry, I'm still at school. So I know that I can factor this into the square root of the first term, which is 7x, the square root of the last term, which is 8. I need one positive, and I need one negative. I always want to then double check those factors just to make sure I cannot factor any further, which for these I can't. So this is factored completely. Okay, so that should be familiar to you guys. Also, something to look out for is if we have 2 terms and they are perfect cubes. So we should be very familiar with our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, etc., etc., etc. You're maybe not as likely to be familiar with your perfect cubes, but being that we just had a lesson on the cubic function, we should be enough familiar that we know 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, and 4 cubed is 64, and 5 cubed is 125. Really, you're not going to see much higher than that. But, you know, you need to be a little familiar with those perfect cubes. Okay, so when you see 2 terms and they're both perfect cubes, we actually have 2 instances where this is going to happen, and we can factor it very nicely. One of them is going to be the sum of perfect cubes. So I see some number that's cubed plus a number that is also a perfect cube, or the difference of those cubes. So again, a perfect cube minus a perfect cube. Both of them are going to factor in the same way. The process is the same, but they look a little bit different. And the way that I remember this process is by an acronym, and that acronym is SCUMS. SCUMS or SKIMS or however you want to pronounce it. It's SCMS. SCUMS. or skims. I don't know, however you want to pronounce that. But that is the acronym that we are going to be using. And so each letter obviously stands for an action, what we're going to be doing. So the first step in both that we need to do when factoring is we simply just need to take the cubic root of those numbers. So if I have something cubed, the cubic root is just that something. Keep the sign and take the cubic root of the last. So the same thing here. Cubic root, keep the sign, cubic root. Then we are going to apply this acronym of SCUMS to this binomial. The first S stands for square the first term. The C stands for change the sign. The M stands for multiply the two terms. And the second S, or the last S, stands for square the last. Okay, so again, SCUMS, square the first, change the sign, multiply the terms, square the last. Notice whenever I square that last term, it's always going to be positive. When I square a positive number, I get positive. When I square a negative number, I still get positive. So the only difference is that sign change for the C, but the process is the same. So again, if you look over to that right-hand side, you see the sum of perfect cubes. X cubed is a perfect cube, and 125 we saw was a perfect cube. So to factor this, we create our binomial. I take the the cube root, keep the sign, take the cube root, right? Then I SCUMS that binomial. I square the first, I change the sign, I multiply the two terms together, and I square the last. And this is factored completely. I cannot factor this trinomial any further. There are not factors of 25 that add up to a negative 5. That's it. So it's a little different, a little strange, but as long as you remember that acronym of SCUMS or SKIMS or however you want to call it, taking the cubic root, keeping the sign first, and then SCUMMing the binomial. So squaring that first term, changing the sign, multiplying the two terms together, and squaring the last. And as you know, you guys are going to get so much practice on this, okay? So that's something new in our factoring. If it doesn't have two terms, maybe it has three terms. When it has three terms, you are going to be, you already know how to factor these when it has three terms. Different things can happen. 3 terms and the a value is 1. Well, that's easy. You're going to use that AC method or that X factor method that we're all used to. That's how we've been factoring. A times C, multiply them, factors of that number that add up to the B value, and you rewrite like normal. Just what we've been doing all year long. Really the same thing for when A is not 1. We're still using that AC method. It's just this time AC method, but then we have to factor by grouping, right? And factor by grouping because we rewrite and then we pair up the first two and we pair up the last two. So you guys know how to do this. And then lastly, 3 terms, it could be a perfect square trinomial. A lot of you tend to overlook these and then you factor like normal and then you realize, oh, this is a perfect square trinomial, which is fine. But if you catch it in the beginning, then you save yourself a little bit of time. The perfect square trinomial looks like a perfect square plus or minus, it doesn't matter, double the root of the first and the root of the last, so 2 times the value of A times the value of B, and then a perfect square at the end. So you see a perfect square at the beginning, a perfect square at the end, and that middle term is always 2 times the root of the first and the root of the last. Okay, again, sometimes some of you are not that great at identifying them, but when you factor it out, you realize, oh, that was a perfect square trinomial because it factors into that root of the first, that root of the last, and then the same sign as the original problem, and then that binomial is squared. Okay, And so again, if you want to do an example of that, we see an example right here in number 4. This is a perfect square trinomial. So let me change colors. This is a perfect square trinomial. 9x squared is a perfect square. 4 is a perfect square. And the middle term is 2 times the root of the first and the root of the last, because the root of the first term is 3x. The root of the last is 2. 3x times 2 is 6x. Times 2, I'm doubling it, is 12x. Because there was a negative here, I keep the negative and I square that binomial. You can always check your work. 3x minus 2 squared. We know that's 3x minus 2 times 3x minus 2. First times first. Outer, inner, last. So you get the same thing. Okay. The reason why it's double is because you're getting that same for the outer and the inner multiplication. You're getting the same thing. So you're essentially multiplying that by 2 or doubling it. All right. So hopefully, like I said, this is just refreshing your memory. Nothing new here, except for the cubic one that we talked about, the scums. And then lastly, if there's 4 terms, we are just going to be factoring by grouping, just like we do when the a value is not 1 and we have 3 terms. We're actually going to do the same thing when we have 4 terms. So look for that GCF, take one out or not take one out, whatever. And then you're going to look at the first 2 terms, pull out a GCF, last 2 terms, pull out a GCF, and then you get your 2 factors. And as always, you want to check those factors to make sure you can't factor any further. So like I said, the only real new information here is the sum or the difference of cubes. And so we've practiced it once. We'll obviously practice it again. So let's look at example 3. So we know that our first step always in factoring is looking for that GCF. And in number 3, I do see that I have a GCF of 2. Now, you don't have to do this, but for this problem, I tend to want to see my variables up front and then the constants in the back. So kind of rewriting it in that standard form, if you will. So if I take out a 2, or really I can rewrite this maybe as negative 2x cubed plus 54, which is really the same thing as 2x cubed minus 54. Either way, it doesn't matter. Typically, it's a little bit easier when we have a positive leading coefficient rather than a negative leading coefficient. But either way, my GCF is 2. So if I pull out a 2, I'm left with x cubed minus, what is 54 divided by 2, and that's 27. And looky inside those parentheses. That is a perfect cube, x cubed, minus another perfect cube. 27 is 3 cubed. So this is going to be the difference of cubes. So I keep my 2. I create my binomial. Remember, that's taking the cubed root of the first, taking the cubed root of the last, keeping the sign. And now I scum the binomial. I square the first, change the sign, multiply the 2 terms together, and square the last. So 2 times x minus 3 times x squared plus 3x plus 9. And that is factored completely. Okay. We did number 4. It was a perfect square trinomial. So now let's look at 5. So number 5, the first thing I want to do is look for a GCF. 6x squared plus xy minus 15y squared. Well, not all of them have an x. Not all of them have a y. Not all of them are divisible by a number other than 1, so there is no GCF. So then what I want to do is ask myself, how many terms are there? Well, there's 3 terms. So in 3 terms, it's either a is 1, a is not 1, or it's a perfect square trinomial. Well, this is not a perfect square trinomial because the numbers 6 and negative 15 are not perfect squares. And the a value is not 1, so the a value is not 1, which means we're still going to be using that AC method and then factoring by grouping. So I want to know what factor, so I'm multiplying a to c. 6 times negative 15 is going to give me a negative 90. and I need factors of negative 90 that add up to a positive 1. Well, that's going to be 10 and negative 9. So then I'm going to rewrite and factor by grouping here. So I have 6x squared plus 10xy minus 9xy minus 15y squared. Erase this just to get it out of my way. Okay. Notice when I rewrote that middle term, I keep the same variables. If it was that plus 1xy, then when I rewrite it, it's a 10xy minus 9xy. Okay. Factoring by grouping, I look at the first two terms, I look at the last two terms. First two terms have a GCF of 2x, leaving me with 3x plus 5y. Last two terms have a GCF of negative 3y, leaving me with 3x plus 5y. I'm happy because what I see inside the parentheses is the same. It needs to be the same. So my factors are 2x minus 3y and 3x plus 5y. Looking inside those parentheses, I see two terms, no GCF. It's not the difference of squares. It's not the sum or the difference of cubes. So that means it is factored completely. Okay. Let's look at number 6. Number 6, I see the difference of cubes. I see something cubed minus a perfect cube. That's 3 cubed. So how do we do the factor the difference of cubes? Well, first thing is I create my binomial. Now, if you need to think of this as just x cubed minus 27 to help you out, that's totally fine, and then you can replace the x with the c plus d. But I'm going to leave it as is. So I'm taking the square root of the first thing I see, and that's just c plus d. Minus, what's the cubed root of the last term? 3. So here's my binomial that I'm working with. And what do I do to that binomial? I scum it. I square the first term. I change the sign, I multiply the two things together, and I square the last. Now, that's the whole process of factoring, but I'm clearly not simplified, okay? I cannot do anything with c plus d minus 3. However, I can do something with c plus d squared and the 3 times c plus d. So I really get when I square, when I do that c plus d squared, that's really giving me first times first, outer, inner, last. So that's really giving me c squared plus 2cd plus d squared. Distributing that 3 gets me plus 3c plus 3d, and then plus my 9. So then I want to make sure I cannot combine any other like terms. C squared, no other C squared. Okay. CD, no other CDs. D squared, no other D squared. C, D, nothing, nothing, nothing. So now this is factored completely. And I know it looks strange. It looks like it maybe not, but it is. Okay. Oops. All right. 7. First thing I do is I look for a GCF. There is no GCF. Then I ask myself how many terms it is. It is 2 terms. And then I see, oh, it's the difference of perfect squares. X to the 4th is a perfect square because it's x squared squared. 16 is a perfect square because that's 4 squared. So to factor the difference of perfect squares, I take the square root of the first, the square root of the last, one positive, one negative. So technically I'm done factoring that. Remember, I always say though, look at your factors to see if you can factor some more. Well, x squared plus 4 cannot be factored any further. However, x squared minus 4, that's another difference of squares. I'm subtracting two perfect squares. So then that factors into the square root of the first, the square root of the last, one positive, one negative. Now I double check one more time. Nothing can be factored any further. So there's my final answer. Okay. Moving on. Let's go orange. First thing I look for is a GCF. I'm looking at the numbers 4, 8, 9, 18. Not all divisible by anything other than 1. I'm looking at the variables. Not all terms have that variable. So no GCF. How many terms does it have? It has 4 terms. So 4 terms, we are just going to actually factor by grouping. So that means we're going to look at the first 2 terms and pull out a GCF. And we're going to look at the last 2 terms and pull out a GCF. The GCF in the first 2 terms is actually a 4x squared, leaving us with x minus 2. The last 2 terms have a GCF of that negative 9, leaving us with x minus 2. So now we have 4x squared minus 9 and x minus 2. Can I factor any of these factors any further? Yes. 4x squared minus 9 is the difference of squares. 4x squared is a perfect square, 9 is a perfect square, and it's being subtracted. So to factor that, I take the square root of the first, the square root of the last. 1 is positive, 1 is negative. I cannot factor x minus 2 any further, so there you have your answer. Okay, here's another one. 4 terms, no GCF. So I want to look at the first 2 terms and the last 2 terms. First 2 terms have a GCF of x cubed, leaving me with x squared minus 4. Last 2 terms, technically the GCF is just the negative 1, leaving me with x squared minus 4. Good, because I want to see the same inside my parentheses. So that means I have x cubed minus 1 and x squared minus 4. Check the 2 factors. X cubed minus 1 is the difference of perfect cubes. X cubed is a perfect cube. 1 is a perfect cube. So how do we factor that? We create the binomial by taking the cubed root, keeping the sign, take the cubed root. Then we scum it. We square the first, change the sign, multiply the 2 things together, and square the last. Now I'm done factoring this first factor here. Now I need to worry about this factor. Well, that's the difference of squares, which will factor into x plus 2 and x minus 2. And so now I am done factoring. And the last one. We do not see a GCF. And this one looks a little bit different. It is 4 terms. However, notice that I have like 3 different variables. I have x's, y's, and z's. That's something strange that we haven't really seen before yet. So what I want you to do is I want you to look at these first 3 terms. That is a perfect square trinomial. That is like the straight up definition of it. So that factors into the square root of the first, the square root of the last, the sine of the middle, squared. Then I'm just going to drop this guy down, minus z squared. So now I have something squared minus something squared. Well, that is the difference of squares. How do we factor the difference of squares? I take the root of the first, I take the root of the last, 1 is positive, and 1 is negative. And that's it. Okay, this one was a little different, a little strange. Okay, but those 3 variables should have kind of thrown you off. And then looking at the first 3 terms, hopefully you recognized immediately that that was a perfect square trinomial. Okay, last question. Given that 2 is a 0 of x cubed minus 7x plus 6, Factor completely. Well, if we know that 2 is a 0, it is a root, it is a factor, then let's think back to our polynomial operations with division. If I know that 2 is a root, then that means a factor of this polynomial is x minus 2, because when I divided, I got a remainder of 0. So if I have x cubed minus 7x plus 2, and I know that x minus 2 is a factor, what is that going to leave me with? Well, I can do my synthetic division here. I can set it up as 2, 1, 0, negative 7, 6. Drop down the 1, 2, add 2, 4, add. See, I knew it was a factor. But what am I left with? I'm left with x squared plus 2x minus 3. Right? Because that's my quotient here. That's my quotient here. So then I can factor that, or you should be able to factor that, right? That's 3 terms. No GCF. Use your AC method because the A value is 1. Factors of negative 3 that add up to positive 2, It's going to be a positive 3 and a negative 1. So that means I have x minus 2, x plus 3, and x minus 1. So now I've factored completely. Okay, and then as always, you could take it a step further, and then now you know how to graph that polynomial. Awesome job, guys.